Hey guys, this is a quick look at density problems and how you can solve them in this class, or any class, I guess. Not to be like, this is the only class you can use density. Density is a derived unit. Density equals mass over volume. It's called a derived unit because you take two things that you know and then you divide them. So it's not like you can just look at something and find its density. You have to take two measurements, one for mass, one for volume, and then divide the two numbers. But it's a physical property of matter. All things have density. All objects do. Okay. Mass is usually given to you in grams, and if it's not, you got to convert it. And then volume is usually given to you lots of ways, but the two ways that you want are either milliliters or centimeters cubed. Those are the two things that you want. And then when you divide them, grams and milliliters or centimeters cubed, the label that you get for density is grams per milliliter or grams per centimeter cubed. They mean the same thing, so you can use either one. Which one do you pick? It's up to you. Okay, so we're going to do a couple practice problems. I think you've seen density before. My daughter knows what density is, and she is in she's in 7th grade, but she learned it when she was in 5th grade. So, I mean, you've been doing this for a few years. You can use the triangle. Density triangle is super helpful to solve density problems. And I'm not going to, you should probably memorize it if you want to use anything, but here's what it looks like. Density and mass goes there and volume goes there, and they're separated by lines in the middle. And the way that the triangle works is that you cover the one that you want, and what's left is the math that you do. So you want to solve for density. Well, density is equal to mass over volume, the two that are left. You want to solve for volume. Nailed it. Oh no, I did not nail it. Nailed it again. You want to solve for volume? Well, you cover volume. Okay, and then you have mass over density. So volume equals mass over density. You want to solve for mass, well then you have cover it up, and then you've got density times volume because they're near each other. Okay, highlighting is my version of covering it up for right now, so please bear with me. All right, let's get the first problem. It says, what's the density of an object with a mass of 25 grams and a volume of 21.87 milliliters? Pretty simple setup. It's given to you very easily. This would be called, my high school teachers would have called this a plug and chug, where you just shove the numbers into your calculator and then it spits out the answer. So density, density equals mass over volume. That's what we're looking for in this problem. The mass of this object is 25 grams. The volume is 21.87 milliliters. Divide the two numbers. You divide while I divide. It's really fun. 25 divided by 21.87, and I end up with 1.14. In this class, it is perfectly acceptable to round to the nearest hundredth place. So in this problem, my calculator spits out all sorts of numbers. It was 1.14311. Who cares? A bunch of other numbers after that. But here in this class, it's best if you just round them to the hundredth place. So since this was a 3, I kept it at 1.14. And the label for density is, why do I do it? 1.14 grams per milliliter or grams per centimeter cube. Either one is correct. Player's choice. There is my answer. Next one. What is the mass of an object with a density of 5.81 grams per milliliter and a volume of 31 centimeters cubed? In this problem, if you have you want mass, and so again, if you cover up the m here, right, and then the math that you do is mass equals density times volume. So back down here, I would do mass equals density times volume. Shove the numbers in there. The density is 5.81 grams per milliliter. The volume is 31 centimeters cubed. I guess they're the same thing. So technically, you could just make this into centimeters cubed because they're the same. And then when you look here, you have centimeters cubed on the denominator there, and centimeters cubed is on the numerator there. So they cancel out, and what you're left with is grams. But mathematically, 5.81 times 31 gets you 180.11. So 180.11, and the label would be, again, we're looking for mass, so mass equals, label is grams. Cool. Sometimes you have to convert. We talked about conversions in the last lecture, and you're not always given the right information. You have to maybe convert them to something better. So here's an example of something like that in number 3, where we've got it says it's a density of a 1.785 kilogram object with a volume of 3,000 centimeters cubed. Here's where knowing the number line helps you. This is in kilograms, but you need it to be in grams if you want your answer to be correct, right? Because the label would be grams per centimeter cubed for density. So I have to convert it mentally or wherever you're at, I don't know. You have, for kilo is here, and then you have 3 spots, and then the base unit is here for grams, okay? So if I'm, this is from the number line we drew the other day, in the notes, if I want 1.785 kilograms and I want it in grams, I'm gonna go 1, 2, 3 spots to the right. So move your decimal point 3 spots to the right. 1.785 kilograms equals 1,785 grams. And it's density. Density equals mass or volume. There's the mass, and the volume is 3,000 centimeters cubed. So the setup there is that the trick is that you have to be careful of the units and make sure you're paying attention. 1,785 divided by 3,000 is 0.595. Can we call it 0.6? 0.60. And then the label would be grams per milliliter. In a situation like this, on my calculator, it said that the answer was 0.595. I don't care if you wrote those 3 numbers, that's fine. Just when the number spits out lots of numbers on your calculator, it's best to round it to the nearest hundredths place. This is the hundredths right there. And since there was a 5, I rounded up. Okay, last problem. So building on that, in this problem, we have, you can see that another box, and it has a mass there. I want to know its density. We know density is mass over volume, but we're not given a volume, we're given the dimensions of a box. So you have to also remember that volume for a box or a prism is length times width times height, okay? However, in this problem, you can see that 1 is millimeters, 1 is centimeters, and 1 is meters. This one's cool. It's already in centimeters. These 2 are not cool, so we have to convert them, okay? And again, the number line is super helpful to do that. It's great to memorize a number line. It's not gonna hurt you. I'll write it right here. Here's a number line. This is a terrible number line. I feel bad, I'm a bad person, and I'm not doing great work. In the middle, you've got the meters. That's the base unit right here. And then to the side, I've got centi, and then I've got milli. Okay, I want them all to be right here at centi. So take your millimeters, 250 milliliters, and you gotta move it 1 spot to the left. So 250 milliliters is equal to 1 spot to the left is 25 centimeters. And then the other one is 0.015 meters. So it's meters right here. It's got to be centimeters. So 1 step, 2 step. 0.015 is 2 decimal points to the right. So 0.015 meters equals 1.5 centimeters. Oh, why? 1.5 centimeters. Oh yeah, I could just do this. Look at that. I'm cool. Anyway, so now you've got the 3. You've got also the 34 centimeters. And now you can plug all of those in to find the volume. So volume equals 25 times 1.5 times 34. 25 times 1.5 times 34. And you get 1275. That would be centimeters cubed, because it's centimeters, centimeters, and centimeters. So that's where the centimeters cubed come from, because you're multiplying all 3 of them together. And then the mass was 150 grams. So if you want to find density, like with the equation right there, you just take your mass and divide by the 1275. So 150 grams divided by 1275 centimeters cubed. This is not my best 5, I get it. And then 150 divided by 1275, I end up with 0.117. We'll just go ahead and call it density equals 0.12 grams per centimeter cubed. So this was all over the map. It was fun. There's a good primer on what density is, how it works, and how you might use it in this class. The tricks are, as I mentioned, you can use the triangle. That's super helpful to use. You can use, and then you have to be aware of, when you are converting, numbers have to match up. So sometimes if you're given a different number, like kilograms there, or millimeters or meters there. You might have to do a little bit of conversions, a little bit of side work before you plug things in. Anyway, this has been really enjoyable, so good visit, and we'll see you soon. Bye.